So I hope you are all doing well. And I just wanted to tell you that our first day of notes here is going to be a repeat of what our very last day was together when we were live and in person that last Friday. Not when I say last Friday, I mean the last Friday day of school that we had together. So you'll see that this is something that we've already seen before. If anybody was absent, I just want to kind of practice a little bit with the recorded notes to make sure that you guys are good to go. So we're on our unit circle stuff, and normally when we're live and in person, I would ask if you guys have any questions. I am going to say that if you do have questions, I'm going to be working on ways that we can have some kind of conferencing so that way I can get questions answered for folks in a timely fashion. In the meantime, shoot me emails so we can figure it out along the way. And what we're talking about here is the unit circle. So when we reference the unit circle, we're talking about a circle that has a radius of 1. And so that's what I've got itemized here. For some reason, my Chromebook at home is not letting my typing show up here. So this is the ordered pair 0, 1. To the right here, we have the ordered pair 1, 0. Again, I don't know why this isn't showing up. At the bottom of our unit circle, we have 0, -1. And then on the left side of our unit circle, if we go to the left 1 spot, we have -1, 0. So all I did is I went out 1 spot from the center of the unit circle. So again, here's the center of our circle. If I went out 1 spot, I'd have another spot there, and that would be a radius distance of 1. I could go another spot in a lot of different locations. I could go over 1, and that would be a radius of 1. I could go over 1 here, and that would be a radius of 1. And they'd all have a variety of angles there. So what we need to do is discuss, well, what happens if you have, say, some sort of a generic triangle. So I'm going to keep this generic, and let's go back to quadrant number 1, and here's my green. Let's look for this green triangle, and I'm going to drop a perpendicular here and connect it. And that makes not just any triangle, but a right triangle. And I'm going to refer to this angle that is the reference angle connected to the x-axis as theta. And for lack of, I don't know, creativity, or just because of this is our normal directions, I'm going to call this our x distance because it's going to the left and to the right. And I'm going to call this the y distance because it's going up and down. And that's going to be pretty typical whenever you talk about unit circle work. And according to our good old friend SOHCAHTOA, if I start looking at my green triangle over here and I start setting up some relationships, I could say that the sine of angle theta is equal to the opposite side over the hypotenuse side. And on our green triangle, y is the opposite side and 1 is the hypotenuse side. So if you write it like that, it's a little bit silly because y divided by 1 is just, of course, y. So we can say that the sine of theta is equal to just simply y. And that's an important aspect because that means that if you are on the unit circle and you have an ordered pair x, y, that means that the y value is the answer that's represented once you take the sine of whatever that angle is. So that's kind of a big, big leap right there. We can do the same kind of thing for cosine. We can say that the cosine of the angle theta, again, let's please all look back at this green triangle over here. Looking at this green triangle, I'm circling it with my pen, if you guys can see that. Cosine of the angle is adjacent side over hypotenuse. That's what SOHCAHTOA tells us. And so if I take the adjacent side, that's x, and if I divide that by the hypotenuse, that's 1. And we're back in the same position of some kind of a silly fraction there. And we can say then that the cosine of angle theta is equal to just plain x. In other words, on our unit circle, this x and this y are the same as what you would get if you take the cosine of theta and the sine of theta. The cosine of theta, the answer to that trig relationship is the value to x, and the answer to the sine of theta is the value of y. So I'm just going to go ahead and box this up and highlight this as something that's really important for us to make sure that we remember and we know moving forward. And then if that's what we get from sine and from cosine, the thing that we want to, of course, be very mindful of is the fact that if you have to find something like tangent, because we will, if you have to find something like tangent, tangent according to SOHCAHTOA is equal to the opposite side over the adjacent side. So that would be the y divided by the x. We will be working with that more on the next day of notes. For now, we can just say that since the y value is what we got there from sine and the x value is what we got there from cosine, we know that the tangent of theta is equal to the sine of theta divided by the cos of theta. And so that's another relationship that we're going to be able to use in the future for this particular homework assignment. And some of you have already done this assignment, but you might want to take a moment to look back on it just to see if you really agree with what we came up with before. We said that for this first triangle here, we're going to go ahead and use our calculators and find the lengths of those missing sides. So we know that we can refer to this as being the opposite side and this as being the adjacent side. And then we know that if our angle is 70 degrees, we can say that if I refer to, again, this vertical distance as y, we can say that the sine of 70 is equal to opposite over hypotenuse. So that would be y divided by 1. And y divided by 1 is just y. And if you type sine of 70 into your calculator, use your calculator, use Desmos, anything is fine with me at this point because we're not live and in person anymore. So just use a calculator and I get 0.94 equals y. If you're using a different calculator than normal, just double check that you're in degree mode. And so that means we can go back over to our little triangle over here and say that this is a value of 0.94 approximately. Of course, we're rounding there. And then let's find the other side of that particular triangle by using a different trig relationship. So now I'm going to set up cosine of 70. According to SOHCAHTOA, cosine is equal to the adjacent side over the hypotenuse side. So that's going to be x divided by 1, which again is kind of some silly fraction because, oops, sorry, I started writing sine, because x divided by 1 is just x. In other words, the cos of 70 is equal to the x value. And if you type cos of 70 into your calculator, you get 0.34 equals x. So I'm going to go back over here to my handy triangle and say that this would be a distance of 0.34. What I want you guys to be able to do is to use those two numbers and draw a triangle in this new and improved unit circle that we've got here. It says use your values to find the sine of 250 and the cos of 250. So before you get going on this problem, you need to remember that you've got to figure out your reference angle. And we said a reference angle is always an angle between the terminal side of your angle and the x-axis. So 250 degrees, folks, is going to be somewhere in quadrant 3. If I put 250 right here to indicate that angle, and our reference angle is going to be right there, that's theta. So our reference angle is going to equal 250, subtract off 180 for a total of 70. In other words, if we draw out this triangle, our reference angle there is 70, and this triangle is again a right triangle, and it's going to have some value of x and some value of y. Based on what we said earlier, we said that connected to the angle of 70 is our adjacent side, and that x value is 0.34, which means that this particular x value would be negative 0.34 since it's going to the left of the origin instead of to the right. And then our y value would be this value that's going down. I'm just going to put the equals on the other side of the y. And since our y value over here, we said opposite of the 70-degree angle is a 0.94, based on this sketch on this triangle, our 0.94 is going down, so we're going to have negative 0.94. And we know that sine is always a y value of some sort. So the y value in this case is negative 0.94. And cosine is always some sort of an x value off of our unit circle. So the x value in that case, would be negative 0.34. And there's our answers for sine and cosine of 250 degrees. So let's try the next one. And I think it's going to go fairly quickly now because once you see some of this stuff, you'll start catching on. And again, I'm going to go back up here and I'm going to say that this was x equaled 0.34 and y equaled 0.94. We just have to figure out where in heaven's name 470 degrees is located. So before we can do anything with 470 degrees, we got to come up with a coterminal. So a coterminal angle would be whatever you get when you take 470 and subtract off 360, because remember, all coterminals are 360 degrees apart from one another. And if you do that math, you end up getting 110 degrees. Once you know that your coterminal is 110 degrees, you can place 110 degrees on your unit circle and then draw a triangle in your circle. And that triangle is going to have an x value and it's going to have a y value. And it's going to be a right angle. And guess what? What kind of reference angle do we have in this particular situation? I'm just going to put REF for our reference angle. We know that 180 degrees is halfway through the circle, so our reference angle in this case would be 180 minus 110, which is, lo and behold, an angle of 70. So again, I'm going to put my little 70-degree angle right there, which gives us the right to say that this y value, since it's going up and down, would be the same y value. Since it's going up, it's going to be a positive 0.94. And this x value, since it's going to the left, is going to be a negative 0.34. In other words, sine, in order to answer these questions that we're given, sine is the y value from our unit circle, and the y value on that unit circle is positive 0.94. And cosine we know is the x value off of our unit circle, and that x value is negative 0.34. Hopefully everybody sees that that's negative because it's directionally going to the left, and y is positive 0.94 because directionally it's going up. Okay, let's go into the next one. And our next one again shows us this same triangle. So let's make sure that we identify that x is 0.34, y is still 0.94. Negative 20 degrees is not anything that we want to work with. So we're going to find a coterminal. Nice handwriting, huh? So in order to find a coterminal, we're going to take our angle and we're going to add 360 degrees onto it to get 340 degrees. So I can clearly place 340 degrees on my unit circle by saying that that would be somewhere in quadrant 4. I'm never going to be drawing these for accuracy, so you guys can always feel free to do the same. You can just stick a line in that quadrant and call it good. I am going to make my triangle. And then, of course, our next objective is to figure out our reference angle. So our reference angle is always the angle between our angle and the x-axis. So if I complete a unit circle, I'll have 360 degrees. In other words, our reference angle is the answer that we get when we take 360, subtract 340, which is 20. If some of you are like screaming 20 degrees at me right away, that's totally fine. I'm just glad that you can see that this reference angle is 20. But we run into a serious problem here. If that reference angle is 20 and I have a 90-degree angle here in the corner, then that means 70 degrees is located down here. And if 70 degrees is opposite from 0.94, then that means 0.94 turns out to be the x value on this particular triangle, not the y value on the triangle that we have in this unit circle. And then connected to the angle of 70 is the side of 0.34, which means the 0.34, look at this little triangle up here in the top, is opposite from side 0.34. So 20 degrees is going to be opposite side 0.34. In other words, the y value on our triangle in our unit circle is going to be negative 0.34. So you have to look really carefully at that one in order to be able to get it right. And then, of course, use those numbers to be able to answer the question. We know that sine is always the y value, and the y value on our unit circle is negative 0.34 this time around. And then cosine is your x value, and the x value on this particular portion of our unit circle is positive 0.94. So hopefully you guys were able to see that this one has a different reference angle of 20, but 20 and 70 and 90 make up a right triangle. So then we could still use the same numbers of 0.34 and 0.94. It's just that our x's and y's got switched. So let's try this last one then here. If I give you guys an ordered pair on the unit circle, then can you tell me what the sine of theta and the cosine of theta are based off of just simply these numbers? And so remember, what gives you the right to be able to do stuff here is that you're talking about the unit circle. And we know that on the unit circle, sine is always given by the y value. So the y value in this case would be 0.743. And that's all you got to do to get that answer. It's really fast and simple. And cosine, we know on the unit circle, is always the x-coordinate. And so the x-coordinate at that particular point is 0.669. Sorry, I was going to put 99 instead of 69. And so that's our answer there. And then we're just done. We don't have to do any calculations. But then what comes up is the fact that we have to find the angle theta itself. So I'm just going to kind of delineate these from one another. In order to be able to find the angle theta, we have to do some other math. And this is when we have to think, well, if sine of theta is equal to, so let's all look at this now, please. If sine of theta is equal to 0.743, then that means theta must equal the inverse sine of 0.743. We could also look at the next statement and say, since cosine of theta is negative 0.669, then that means theta must equal the inverse cos of negative I'm just totally fumbling that. The inverse cos of parentheses negative 0.669. If you could please type both of those into your calculator, what's going to happen is that sometimes you're going to get answers that are the same and sometimes you're going to get answers that are different. And I don't want you guys to fumble or think that there's anything wrong with either of these two answers. On this first one, if I do angles to the nearest tenths place, please, we get inverse sine of 0.743 to be 48 degrees. And on the next one, inverse cos of negative 0.669 is 132.0 degrees. I'm just using my calculator for those. Now, those two answers are different because we have to be smarter than our numbers. So let's go back and let's make this a triangle. And what we've just done is we have to distinguish which one of those answers is going to help us get our full answer of theta. And if you look at what we just did here, theta is going to be this full angle. And of those two numbers, 48 degrees or 132 degrees, which one is the actual theta? And the actual theta would be the one that's bigger than 90 degrees. We can see it on our sketch, 132.0 degrees. There is our theta. So that means, what the heck is 48 degrees representing? So if you look at your triangle, does everybody see where 48 degrees actually belongs? Yeah, 48 degrees is this reference angle. So that's the piece that we need to keep in mind. All of our calculations are correct. We just have to know how to interpret our answers in order to be fully correct. And then it's a matter of being able to download the worksheet. Try to download it in Kami, and see if you could try to submit it to me. So some of you, if you've already done the assignment, take a picture, send me the PDF of the picture. You can either send it to me as an email attachment, or you could try to download it in Schoology. One way or another, as long as I get that day 4, that would be super fantastic. In the meantime, I need to make sure to check in with you guys. So if nothing else, I need everybody to email me back an answer to this question, because this is how teachers are going to do attendance, is I'm going to ask you a question every day, either posted on Schoology or through the recorded notes. And I'm just going to ask you to reply back to me using my email address. And I'm tmeuser@isd191.org. So could you give me the name of a movie? Oops, I can spell name. Give me the name of a movie that you've watched in the last 5 days. If you haven't watched a movie in the last 5 days, give me the name of a movie that you'd like to see shortly or in the next 5 days or something like that. Or if you don't have either of those, give me the name of a movie. So just email me back and tell me the name of a movie, and that's how I'm going to know that you paid attention today, and I will record your attendance tomorrow appropriately. All right, you guys take care. Catch you later. Bye-bye.